Yeah, so today basically I wanted to cover this time complexity and some problem,
Hmm.
right?
Okay.
So let's, since Rama and Indra are not here, let's see, we'll do a short class
Okay.
and let's go through time complexity first, and probably then depending on the time we will pick up a problem. Okay.
Okay.
So let's see. So let's say the time complexity, right? Right. Okay.
Of graph, right? Yeah.
No, not graph,
Oh, okay.
just in general.
Okay. Okay.
How, right? So
Yeah.
basically what time complexity is, that how does, with the increase in number of input in your program, how long does it take to execute the program, or the same number of operations, how many times does it execute, right?
Yeah.
So
Hmm.
let's take for example this function or this for loop which says for integer I is equal to 1, I less than n, less than equal to n, and I plus plus, right?
Yeah.
And then this function, all it does is, let's say, print f, and then it just print whatever it is, right? Percentage d backslash n, and it just prints n, nothing else, or I, sorry, not I,
Hmm.
but I. Okay,
Yeah.
it prints I. So if you see, um, like this function, it iterates n times, n number of times, and this
Yeah.
operation or this instruction it is executed n number of times, right? So
Yeah.
that means, you know let's say this is your input, and this is your the execution, right?
Yeah.
How many times it executes. So this is 0 and whatever, it is increasing number. Then let's say this is your 1, 2, 3 and whatnot, right? And this is n, right? And this is again 1, 2, 3 and n. So let's say if n is 1, then this instruction set, it will be executed one time. If it is 2, it will be 2 times. It is 3, it is 3 times, and so
Three
on,
times.
right?
Yeah.
So if you see, that means the that basically the execution, it increases linearly, right?
Okay. Yeah.
So that's called, so that time complexity is called on. That means, um, with the
Execution
number
speed.
of input, uh, as the number of input increases, basically the time it takes is more linear, it linearly
Yeah.
increases.
Linearly varies. Yeah.
Yes. So now let's say we are doing just printf. Instead of printf, what we do is, let's say before doing that, we do like this, right? Int j is equal to I into I, and then after that we print j. Okay.
Okay.
So this thing, it really doesn't change, it doesn't change the time complexity of this function. It is still on, because this set of
It's on same time.
instructions, basically it is executed n number of times. Okay.
Yes.
And to execute these two instructions, basically it takes some constant time, so it is on, right? So it doesn't
Yeah.
matter, it is on, right? So let's say if we say that just to do a printf function, it takes maybe, let's say, some x seconds, okay, or x
Okay.
time, and to do this it takes some y time, right? So if you see that, then what will happen is that your time complexity is basically o n into x plus y, x plus y. But this x plus y is a constant. So when you consider the time, calculate the time complexity, you do not have to take the constant time into account. So any constant you can remove. So basically you can just say on, right, or something like that. Yeah. So that's what you can do. So now let's say my function is little bit different, where what I do is let's just give the function as a name f1, and my function starts here, and then again what I do is that again I do for int I is equal to 1, I less than equal to n, and my function takes integer n, right, and then I plus plus, and here again I do int j is equal to I into I into I, basically I cube, okay, and then I do printf, and whatever I print j, right. So in this case what is going to happen is that this part is under one for and this part is under another for, right. So you have to calculate the time complexity separately for both of this, right. So as we saw that time complexity for this portion is on, and similarly even for this portion, you know, this set of instruction, it is executed n number of times. So again
Yes.
it is on. So the for this function the time complexity is on plus on, right, because you are doing it 2 times. So that means 2 on, okay.
That is
Now so since the constant part you can always remove, so that means on,
yes.
okay. So that's how basically you calculate the time complexity, but this is more of a linear case, right.
Yes.
So let me just make sure that the recording part